Hello and welcome. A pleasant afternoon to all of you who are watching this webcast. Today, the 19th of August, we start with a very important chapter in statistics, and that is on theoretical distributions. I hope all of you are keeping fine and practicing every day's lessons, going through the videos and definitely making progress. So today we are taking up theoretical distributions. Dear students, please note that this is a very important chapter in your exams. Number one, if you talk about the weightage given to this particular chapter, now almost 6 or 7 problems can be expected in the exams. And apart from probability, if you take the case of probability chapter, in probability chapter we have almost 7 questions which we can expect in the exam. So probability and theoretical distributions together would anyhow they would be anywhere probably they will be giving 14 to 16 questions from these two chapters. So it means almost 14 to 15 marks. Therefore, probability and theoretical distributions are two of the very important chapters, and I would request you to go through these chapters in detail because of the weightage in the exam. Once again, probability we expect 6 to 7 questions. Theoretical distributions also around 6 to 7 questions, because theoretical distributions has 3 parts to it. The first is the binomial distribution, on which 2 questions can be expected. Then we have the Poisson distribution, on which you will have 2 questions. And the third is normal distribution, on which 2 questions can be expected. So both probability would probably account for around 7 questions, 6 to 7 questions, and same for theoretical distribution. So please keep a note of it, because many of you are asking about weightage. Weightage wise, these are 2 of the most important chapters in statistics portion of your curriculum. Now, today we are taking up, first of course, is the idea of probability distributions. We will first go into what is random variable. So please open chapter 17 and we shall be following the study material very closely. We will first talk about random variable, then discuss about what is a continuous variable and what is a discrete random variable. Then we shall move into the types of probability distributions, and you will see that there are 3 types which are there in our curriculum. For our study purpose, we have the binomial distribution, we have the Poisson distribution, and the third is the normal distribution. Now, binomial and Poisson are examples of discrete random variables, and in case of normal, it's a continuous probability distribution. So we shall discuss about that. We will also go into details of the properties of binomial, because today primarily we'll focus on binomial distribution. So we shall discuss about the properties of binomial distribution, mean, the mode, the standard deviation, variance, and then we shall follow the examples in chapter 17 and complete with number of problems as usual from set A, set B and set C of exercise 17, and I shall also take up questions from the additional question bank, and we shall then continue with the MTP, that is the model test paper May 2020 questions on binomial, and I will also respond to the queries which you have sent in the last session, after the last session on probability. So there are certain clarifications, certain explanations which I shall be giving, along with I shall be solving some additional questions which many of you have requested me to do, and in that way we shall be ending today's session. So primarily we move into binomial distribution today, and dear students, when we talk of binomial distribution, first let me go into what is random variable. Then we shall move into binomial. Now, you see, there are different types of variables. Now, if I say x is a variable and x can take different values in different occasions. So X is a random, it's a random variable and values in different points of time, in different occasions, and some of these values may not be predictable. So these are random. That means you cannot predict. No prediction. Right? So no prediction. Now examples can be, say, the number of cyclones in a season. Right? We cannot, definitely the Met office, the meteorological office tries to predict, but sometimes the prediction cannot be exact. The prediction cannot be accurate. So I'm giving an example, number of cyclones. Okay. Next can be whether there will be rain or no rain, rain or sunny. Okay. The yield from crop, or if I talk about minerals, the yield. Now think of a coal mine. Now they have a huge amount of coal deposit in the mine, but they may not be able to predict what will be the total yield. That is the total output they will be getting. Okay, so this is something which is unpredictable, and these values will be different for different seasons, for different occasions. Okay, so these are examples of random variables. Similarly, if you talk about some more examples like, say, the pressure, you know, the atmospheric pressure. If I talk about another parameter, temperature, well, these are very difficult to predict with 100% accuracy level. So these are examples of random variables, and primarily in theoretical distribution, we shall deal with random variables. Please also note that your understanding of probability chapter is very important, because probability, the basic knowledge of probability which you must have developed. For example, P, A plus B, what is a conditional event, what is meant by, say, for example, independent event. These knowledge, these inputs will be very important for you in this particular chapter on theoretical distribution, because we shall primarily deal with variables, and the concept of probability will be there in almost each and every numerical which we shall be solving within this chapter. So the understanding of probability is fundamental for you in order to understand this particular chapter on theoretical distributions. Now, random variable find. So we can see so many examples of random variables from our daily life, starting with pressure, temperature, the crop yield, mineral yield, etc. Now, some of these, random variables are of, in fact, these are of two types. So random variables are of two types, and the first type is what we call discrete variable. It's known as a discrete variable, and the other is a continuous variable. Okay, so I would request you to keep your pen and paper handy, and let us understand each of the concepts. So the first concept we have started with is random variable. I am writing the main points here. Random variable, discrete and continuous. Okay. Now, what is discrete and continuous variable? Random variable means any variable which can take different values, which can assume different values on different occasions or over different periods of time. Maybe according to season, maybe according to year, maybe according to month, the data will change. Okay, so this is an example of a random variable. Now, random variable is of two types. It can be either a continuous variable or a discrete variable. Now, what is a discrete? Let's first start with discrete variable. What is a discrete variable? Discrete random variable. Discrete random variable means a particular variable which can take any value in a given range, but these values are countable values. So in case of discrete variables, they can take a value, but these are countable. Now I'll take the example of some discrete variables. say the number of cyclones. This can take certain values, many values within a given range, but it will be countable, number one, and it is a countable set, or sometimes it might be countably infinite. But it can be countable, ultimately, countable. Number one. Number two is, say the number of defective parts. So when we talk of discrete, I am writing certain examples. Number of defectives. Number of defectives in a machine, right, or in a factory where certain items are being manufactured. In a batch of 100 articles or in a batch of 1000 articles, how many defectives are there? So this is an example of a variable, no doubt. It is a random variable. Why? Because you cannot predict with 100% certainty about how many defective parts will be there in every batch in every month. So it is a random variable because it assumes different values over different occasions, over different points in time, over different periods of time. Okay, fine. Therefore, it's a random variable. Secondly, it can only assume, definitely it can assume any value, but the values are specific values. For example, you cannot have, definitely you can have 5 defectives, you can have 6 defectives, you can have 200 defectives, but you cannot have minus 5 defectives. So negative values, no, not possible. You cannot have 3 by 2/7 defectives. Fraction, no. That means defectives can assume only integer, and that also positive integers, whole numbers. So this is an example of a discrete random variable. So the first example is, I'll take 3 for example so that you can understand. First is the number of defectives. Second you can take is, say, number of scratches on a surface. Now when, say for example, an LED TV is being manufactured, LED, right, which has to have a smooth surface. After the production is over, the quality control department of that particular manufacturing company will check whether the LED portion, the front portion of the TV, has any scratches or not. You are buying a new car. Definitely, as a buyer, you want to see whether the car is absolutely scratch-free. If you find a scratch somewhere, you definitely might tell the vendor, the seller, to change the car or to change the, that particular component. So therefore, number of scratches on the surface. So number of scratches on the surface. So number of defectives, number of scratches on the surface, number of cyclones, right? Number of cyclones. You can have any number of cyclones, but not fractional amount. Number of scratches. Yes, you can have 5 scratches, 10 scratches, 1000 scratches, 777 scratches, but you cannot have 10, say for example, 10.3 scratches. No. So these are discrete. Discrete, when we use the word discrete, it means that there are specific values which X can assume. So in case of a discrete random variable, the variable X can assume certain specific values. Definitely it can assume any such specific value within a given range. For example, in a company it might be observed that the number of defectives lie in the range, say for example, between 5 and 30. Yes, the number of defectives can assume any value between 5 and 30, but here the word any value means certain specific values. All integers, 5, 6, 7, 8, 9, 10 till 30. Yes, the number of defectives can assume any of the whole number values, integer values, but it cannot have a value like 27, 1 by 5. No, it can have 27. It can assume the value 28, but not 27, 1 by 5. Right? So this is an example of certain values which are random values random numbers, and these are discrete random variable. Now we'll look at certain different type of random variables which we will call continuous random variable. So you can see that variables are of two types. We have random variables are basically of two types. You can have a discrete random variable or you can have a continuous random variable. So in case of continuous random variable, as the name, what is the name? Continuous. That means what? Without any break. If I say a continuous line, that means I am drawing a continuous line without any break. If it is a continuous straight line, okay, continuous straight line, but no breaks. If it is a curve, okay, fine, a continuous curve, but no breaks. That means continuous variable or continuous random variable means a variable x which can literally take any value within a defined range. Any value. Here any means any. It can take any values. That means a fractional value, integer, whole numbers, fraction, any value, no restrictions, no conditions. For example, let's take few of the instances. Say maximum temperature. Okay, the maximum temperature in a day, it can literally take any value. It can be 37.334 degrees Celsius. It can be 42.11567 degrees Celsius. It can also be a round whole figure, 40 degrees for example. So something, a parameter like temperature can take any, literally any values. So it is a, if you actually plot every day a continuous curve, okay, no break, it can take any value. But in case of discrete, yes, it will have breaks. It will have breaks. So this is a discrete variable graph where these circles represent the value which the discrete variable cannot get. Right? For example, coin tossing. Right? Now, coin tossing, you can have either success or failure. In case of, say, a tossing of a dice, right? When you are, say, tossing a dice, it can have certain outcomes. You know, these are called events. Maybe the first throw of the dice, you get 3. Second throw, you get 6. Third throw, you get 1. So it can only assume 1, 2, 3, 4, 5, 6. Certain specific numbers. Yes, it can take any value within the range 1 to 6. If the range is 1 and the highest number is 6, it can take any value, but the value will be integers. It will be whole numbers. It is an example of a discrete random variable. Right? So in case of the discrete variable, yes, there will be breaks, but in case of continuous variable, it's a continuous curve, no discontinuity, no gaps, and literally it can assume any values like maximum temperature. Now say the voltage in case of electric current, voltage, which also measures one of the important parameters in current electricity. Right? Say for example, pressure. Pressure can take any value. Now in the petroleum industry, you see when the crude oil is actually the mineral is extracted from below the earth's surface, then there is a process of distillation of that. And this is how petroleum is actually formed, is manufactured. Now the petroleum passes through pipelines. So in the pipelines, the pressure is very important. And the pressure may change according to atmospheric pressure, external pressure. So pressure can assume any values. Temperature can assume any values. Rainfall can take place in any, it can be 15 millimeter, 14.99 millimeters, 13.65 millimeters, any. So these are examples of continuous random variables. So weight, height, pressure, maximum temperature, crop, minerals, the amount of extraction you can do from minerals. these are examples of continuous random variables. So, dear friends, we can see random variable is any variable which is unpredictable. It can take any value, different values in different points in time, according to seasons, according to months, according to quarters, according to different phases. Okay, financial year, for example. So that is the essential meaning of a random variable. Random variable can be of two types. It can be a discrete random variable or it can be a continuous random variable. In case of a discrete random variable, it will only take up specific values within a given range. Yes, it can take any specific value within a given range. But here, any means that it cannot take certain values like fractional values or negative values. In case of continuous random variable, yes, it can take any value within a defined range, but it can also take fractional values. So in case of the discrete, we say that it's countable, but in case of continuous random variable, it is uncountable, infinite. Because it can assume any value, therefore, it is uncountable, you cannot count it, and it is basically infinite number of values. Uncountably infinite. But in case of discrete, we will call it countably infinite. Yes, for humans it is, possibly it is, I would say, very difficult, very challenging for somebody to count. But if you have a supercomputer, maybe you can count. So it is countably infinite. But in case of continuous, it is uncountably infinite. Even a supercomputer cannot count it because there is no end to the number of values which X can assume. So this, dear friends, is the basic difference between random variable and continuous, discrete random variable and continuous random variable. This much of knowledge is enough for us for our exam purpose. And now we move into what is called a probability distribution. Now, we will move into 17.1. So I would request you to keep a note of portion 17.1 part of our study material of chapter 17. 17.1, we are moving into 17.1, and our understanding of random variable will help us in order to understand what is probability distribution. Now, since a random variable can take up any values, of course, any here means if it is a discrete variable, it can take certain specific values within a range. If it is a continuous variable, it can take up literally any value within a defined or within a given range. Fine. Now, if you keep a note of what value it takes in the first quarter, second quarter, third quarter, in this way. Or for example, if you're tossing a coin, say 5 times, 10 times, if you write down that first toss, it is head, second toss, again head, third toss, it is a tail. In this way, if you write that what are the values it can take. So if I, build up a small table like this, where I write what is the value it takes, and if I also write the probability of the value. So here I am writing the probability and here I am writing the value. So okay, this is head, fine. Value or outcome, I would write it this way, outcome. So toss 1, toss 2, toss 3, 4, 5. Head. Next one is head. Then third is tail. Again tail, again tail. So I write the probability also. So all 0.5. Okay, each 0.5. So it gives me an idea. What outcome, what probability, how many times. Okay, so in this way we can develop a table, and this is the basic concept of probability distribution. So if you measure a random variable many times, you can build up a distribution of the values it takes. Here of course we have taken outcome. Now if you take values, like for example, I'll just change this column and say we are taking up say for example, number of defectives. Okay, so number of defectives and the probability. Defective, say the defective is one defective. 1. What is the probability? Let's take a random probability. Say it's 0.15. Defective, 2 defectives. Okay, say the probability is 0.20. Having 3 defectives, value is 3. That means here, x or the random variable, it is 1 here, it is 2 here, it is 3, x is 3, x is 4, x is 5. So the probability that x is 1, that is the random variable is 1, that means you have 1 defective. Say it is 0.15. The probability that there are 2 defectives, so 0.20. These are, I am taking just approximate, this is just on the spot values. The probability that there are 3 defectives, say we will take 0.4. The probability that there are 4 defectives, say 0.2 or 15. Okay. And probability that say there are 5 defectives, the maximum, say it is 0.10. So now if you see, the probability that x is 1, that is 1 defective, is 0.15. That means in 15% of the case, 0.15 I can say as 15%. 0.20, so the probability that number of defectives, so this is a defective number of defectives. This particular graph which I have drawn shows you the number of defectives. Okay, so the probability that there are 2 defectives, it is 0.2. So this means 20%. The probability that there are 3 defectives, okay, say it is 0.4. So this gives me 40%. The probability that there are 4 defectives, that is x is 4, is 15%. So 15%. The probability that there are 5 defectives is 10%. That means this table shows me, please I request you to note down this table, because you see while discussing there are so many points which I try to explain through drawing graphs and tables, which will definitely help you in your understanding of the chapter. And while you revise the chapter for the exams, side by side with the presentation which we are sharing with you from the ECPL, you are able to download, plus the study material, plus these notes, I am sure it will help you for your preparation. So kindly have a look at it, understand it, and please note it in your scrapbook. So here you see defectives, number of defectives. Is it a random variable? Is the number of defectives an example of a random variable? Yes. Is the number of defectives a discrete random variable, or is it a continuous random variable? Dear friends, it is a discrete random variable. I have taken a range, x is 1, that is minimum number of defectives is 1, maximum is 5. So it's a defined range. 1 is the minimum, 5 is the maximum. Yes, x has taken up all the values between 1 and 5, but here all the values means only the whole numbers. For example, here x cannot take up, I'm just writing here, x can never take up a value 3.5. No, it's not possible. There cannot be 3.5 defectives. Either it's 3 defectives or 4 defectives. But fractional number of defectives, no. Unacceptable, impossible. Therefore, you can see this is a discrete. So I will call it a discrete random variable. DRV, discrete random variable. The range is, yes, 1 to 5. That means x assumes the value 1, 2 or 3 or 4 or 5. Okay, so these are the values, right? So these are the values. And this is the probability. Together what you get is a probability distribution. So this whole, this entire, whatever work I have done here is nothing but a probability distribution. I hope you are able to understand. This is the simplest way which I can think of in which you can understand the concept of probability distribution. Once again, dear friends, kindly note this chapter has a lot of importance in your exam. Again, as a chartered accountant, I can tell you, practical life, we use this chapter and the probability chapter together. It gives us a lot of help when we solve complex business problems on behalf for our clients, in the industry, ranging from banking to manufacturing, from IT sector to civil aviation, from pharmaceutical, pharma sector to defense. You name any sector and we use it. Therefore, this chapter is very important. 6 to 7 problems will come from the probability chapter. Again, from the theoretical distribution chapter, this particular chapter, 6 to 7 problems, at most 7 can come. So kindly make sure you are absolutely clear with the concepts. First concept was random variable. Then we talked about what is a discrete random variable, what is a continuous random variable. Now we have taken up 17.1 and we are understanding what is a probability distribution. Okay, so the third important point is probability distribution, which we are now going through. So this whole, what you see here, probability distribution, therefore I can say that probability distribution is simple. It is very simply a chart. It's a chart in front of me. What do I understand as a layman? I don't know mathematics. I don't know statistics. What do I understand from this? Say I am a finance person who has no idea of statistics. It can be so. Say I did economics honors. Fine. And then I did my MBA. So I did not study mathematics. But I am working at a managerial level in a company and this chart is shown to me. What do I understand from this chart? I understand that yes, this is the number of defectives and this is the probability, which means from this part I can easily understand that 40% chance, the maximum chance is here. That means I will understand that there is a 40% chance that the number of defectives will be 3. And the minimum chance is 10% that the number of defectives is 5. So I hope you can understand that this chart also talks about the mean, the concept of mean, central tendency, you see, right? That means the maximum probability is somewhere in the middle, 40%. Okay, so this is also similar to the concept of central tendency. You have already done the chapter on central tendency where you know that 3 of the measures of central tendency are the mean, median and the mode. Also, one of the important measure of center of dispersion, of course, is standard deviation, but standard deviation depends again on the mean. Variance or standard deviation depends on the mean, right? So you can see here what we have is the value and the probability. And please note one important property here. Let me add up all these percentages. I have written it randomly. Let's see. 20 and 15, 35 and 40, 75 and 25 is 100%. That means this fraction which I have written, 0.15 plus 0.20 plus 0.4 plus 0.15 plus 1 will give me total probability is 1. That means whenever there is a defective in this particular plant, whenever manufacturing takes place, whenever there is a manufacturing, there will be defects. First point. Second point, out of the defects, there is a 15% chance that there will be 1 defect. There is a 20% chance that there will be 2 defects. There will be a 40% chance for 3 defects. There will be a 15% chance for 4 defects. And there will be a 10% chance for 5 defects. Are you getting this point? That means probability distribution shows me the distribution. It's distributing. The total probability of 1, please note, you know the total probability is 1. I pass the exam, say the chance is 0.3. I fail in the exam, say the chance is 0.7. I'm not a good student. But total probability has to be 1. a coin, you toss the coin. The probability of a head is 0.5. The probability of a tail is 0.5. Together if you put it, these two are mutually exclusive. If a head takes place, there won't be a tail. If I pass the exam, that means I have not failed. So these are two mutually exclusive. But if you add them, if you put them together, if you bring them together, they become exhaustive events. That means the total probability has to be 1. Okay? You take the example of throwing a dice. Okay? So, you can just draw it. You can draw the table yourself. Right? Based on this particular example which I have done. So, if I just rub it up and you see, when you throw a dice, say you are throwing a dice, a standard dice with 6 faces. Okay, so what will be the table? What will the table look like? Okay. What are the values which, once you throw the dice, what are the values which you can get? The range, of course, let me write here, of course, the title is throwing a dice. Dice throw. Okay, fine. Now, we are assuming that you are throwing a dice once. A single throw of a standard dice. Okay? Hope you are clear? Right. Now, it can, x is a variable. Because you don't know why x is a variable, please ask yourself, why x is a variable? Not because of what I am saying. I can say something wrong. Always ask yourself, why is x a variable? X is a variable, why? Because it may assume any value, and before you throw a dice, you cannot predict with 100% accuracy. So x is a random variable. Yes, random variable. Is it a discrete variable, discrete random variable, or a continuous random variable? Well, it can take any value between the range 1 to 6. So range is 1 to 6. No doubt. But it cannot take a fractional value. So it is a discrete. Not a continuous. It's a discrete value. Discrete random variable. Now, what are the values it can take? So here I write the values. 1, 2, 3, 4, 5 and 6. And now you know the second column is the column for probability. So I write P, probability. For the probability part, what is the probability that there will be 1 will come? 1 by 6. You know what is probability? All of you are experts now. The probability means P of any event means the number of favorable cases by the number of possible cases. Favorable by possible. So, it's very simple, 1 by 6. Probability of 2 is 1 by 6. Probability of 3 is also 1 by 6. 4 is 1 by 6. 5 is 1 by 6. 6 is 1 by 6. The total probability, if you see, the total has to be equal to 1. Okay? So, probability distribution shows you the values and the probability and the total probability. If you add up, value number 1, what is the probability? Value number 2, what is the probability? If you add up, it has to be 1. The total has to be 1. Okay? I hope it's clear to you. So, probability distribution, that means gives you what? It distributes. You see how it is distributed. Total probability is 1. It is getting distributed. Okay. 1/6 is going to 1. Second 1/6 is for 2. Third 1/6 is for 3. I hope you can understand. If I break this into 6 parts, each part is going. One part is going to 1. Second part is going to 2. Third part is going to 3. Fourth part goes to 4. Fifth part is 5. Sixth part is 6. If you think of this as 6 friends and this is a cake. So say it's a cake. Okay, so it's a cake. The birthday cake or whatever. Okay, now you are splitting the cake. 1/6 is going to 1, the first friend. So I am splitting it. Instead of eating it alone, I am splitting it. I am breaking it up, cutting the cake. First part is going to first friend. Second part going to the second friend. Third part to the third friend. Fourth to fourth. Fifth to the fifth friend. Sixth one going to the sixth. So I am distributing the probability like this, giving to 6 friends. Think of it in this way. Probability distribution. Probability distributed. Distributed to what? Distributed to different values. Okay, here I am taking examples on a lighter vein. Imagine 6 of your friends are there. Now it's your birthday. Okay, or say for example you have completed successfully. I pray to the Almighty that all of you become successful in the coming exams. But once you are successful, once you get the good news in the month of January or February next year about your passing of your CA foundation exams, a lot of friends will come. They'll ask for party. Their 6 friends might knock at your door and say, "Hi, you have cleared the exams. What about party? It's party time." And you are there with a huge piece of cake or a pizza, whatever. Now you have to break the pizza, you have to break it up into pieces. You cannot have it alone. So you are distributing the pizza, you are distributing the cake to 6 of your friends. Same here, the probability is getting distributed to different values. Here friends, 6 friends instead of 6 friends, they are 6 values. 6 possible outcomes. Are you clear with this? I hope you are able to understand probability distribution. Why I am spending time? Because if I don't understand probability distribution, this basic concept, it will be very difficult for me to go into Poisson and normal distribution. We should be crystal clear what probability distribution means. The good news for you, the very good news for you is for binomial, you just need to remember one formula. For Poisson, you need to remember one formula only, and for normal also one formula. So I will trouble you with only 3 formula. I won't trouble you much. This is my last 3 days of session with you. I will not trouble you much. I will only request you to remember 3 formula. But my earnest request to you, please understand the probability distribution concept. Once you know this, the rest of it literally will be I drew a cake. So the rest of it, since I drew a cake, I will write the rest of it. If you understand probability distribution, the rest of it will be a cake walk. You can just have a cake walk. So I drew a cake here, so I thought of making a pun and making it cake walk. Okay, so definitely don't worry. So this way is the best way to understand what is probability distribution. That means you are distributing the total probability into different parts, each part for a specific value which the variable can take up. Okay, so that means if you have such a distribution, it is also natural that, as I said in the example on the defectives, right? You found out in that particular chart, I drew the probability in such a way, you had the maximum probability of 0.4 for 3 defectives. So you get an idea of mean. Okay, the central tendency. So every probability distribution will have mean, it will have mode, it will have variance. And we shall see what is the formula for the variance and for the mean as well. So this is what we understand by probability distribution, 17.1. Also, I will request you to note few more points. Okay, so few more points. First is, in case of binomial. Now, probability distribution, let us break it up. I am writing PD, probability distribution. So, for discrete, they are divided again into 2 parts, discrete and continuous. Okay. Discrete probability distribution means the probability distribution of those random variables which are discrete in nature, discrete, like number of defectives. Okay, so where there are, say, 2 outcomes. So, discrete. Examples of discrete probability distribution, number 1 is binomial, and number 2 is not Poisson, but Poisson. So French, we'll do it tomorrow. Not Poisson, there is nothing called Poisson. No poisonous substance in statistics. All are healthy for us. Mathematics, statistics, very healthy for us. Good food, nutritious food for us. No poisonous substance. So even though many people call it poison, but it's Poisson. So I will spell it like S-S-O-N-N, French. Okay, Poisson. So this is Poisson. So this is discrete. And when we do the normal distribution, you will find example of continuous probability distribution is the normal distribution. Okay. The institute has broken down this chapter into beautiful subchapters. Subchapter number 1 is binomial, which we are doing now. Second is quasar, and the third day, the last session which I have with you is for normal distribution, which is a continuous probability distribution. Okay. Also, please note, you can now understand that for binomial, certain assumptions are there which we now will go into. But please note that binomial distribution, which is our subject matter for today, has a lot of important, I will say, applications. For example, in any type of genetic experiment, right? Genetic, when we talk of genetic engineering. Okay, also in microbiology, right? Microbiology. Okay, when we have examples, say for example, the pharmaceutical sector, pharma. So this binomial probability distribution has a lot of applications. Ideally, binomial is used. The word bi means two. Bicycle, 2 wheels, 2 tires. Okay, bimodal, that means 2 modes. You know what is mean median mode. Bimodal means 2 modes. Bicycle. Okay, bi means 2. Biannual, twice a year. So binomial. Okay, binomial. This means that this type of distribution is based on 2 outcomes. That means binomial distribution is for those random experiments which has only 2 outcomes. So I will write 2 outcomes. Okay, number 1, we should know the features. 2 outcomes, that means 2 alternative possibility. 2 alternative possibilities. Number 1, first feature. So therefore, when you deal with problems, say in the exam you find a problem coming in a throw of say a coin is thrown 10 times. What is the probability that there will be at least 4 heads? So when you see this problem on coin tossing, you should think. If you are asking me in the queries that, sir, how to know which one is binomial, which one is quasar, which one is normal, you may have a question in mind. Many people keep asking me sometimes. Now the answer is that when you see the problem, you have to understand the type of problem. If the problem in the exam is on coin tossing, it means that you need to apply binomial distribution, because binomial distribution deals with those random variables or deals with those experiments where there are 2 alternative outcomes. For example, head or tail. Now in a hospital, for example, maternity ward, right? Children, babies are born. Boy or girl, 2 outcomes, boy or girl. In case of genetic engineering, in case of microbiology, a research is going on. Success or failure. Now today you see so many countries in the world are all struggling to find a vaccine for the deadly coronavirus. You have already seen in the media, Russia has gone 1 step forward. UK is also claiming that they are coming out with a vaccine. Some of the leading organizations, medical institutions in India also are trying hard, and we all are looking, the entire mankind is looking forward to a vaccine. But when you have a clinical research, you have 2 outcomes, either success or failure. There is nothing in between, right? Either I pass the exams or I cannot. There is nothing in between. So these are dealt with under binomial distribution. Please keep a note of it. So these are practical applications of binomial distribution, and through this, like I showed you the example of defectives, either it is a defective or it is not a defective. That means it can be sold without any tension, without any headache. There will be no rejection from the customer side because it is not a defective. Okay, so coin tossing, head or tail. I was talking about research, success or failure. In case of defective, either a good product or a defective product. either a sellable product or a non-sellable product. See, two outcomes. So these type of problems, if you get in the exam, please note that you have to use the binomial probability distribution to solve these problems. So, dear students, you can also note that binomial distribution helps a lot in making short-term projections. So I will write, it helps in short-term projection. That means short-term predictions. Right, I showed you the example of defectives and the first chart which I drew. So any manager from that particular chart can understand that, okay, the maximum probability 40% is for 3 defectives. So accordingly, he can make a projection, he can make a prediction, and he can accordingly try to control that so that the number of rejections come down, the number of defectives come down. So it helps in decision making. That is why I said earlier in my discussion that this chapter on probability and the chapter on probability distribution or theoretical distribution is very important from a chartered accountant's point of view. We use these principles almost on a daily basis for our clients in different industries. Okay, so this is basically what is the concept of discrete probability distribution, and we saw that example of discrete probability distribution is binomial and Poisson, and for continuous probability distribution, the example is normal distribution, which we shall be doing at the end. Now we will take two important terms. We will add two further terms. Okay. So we have discussed about the types of probability distribution. Now we go into the terms. What are the terms? Okay. First one. Now, we saw that what is a probability distribution? It shows you the values which X can take, plus it gives you the probability of each of these values. Okay, I am giving one more example. Say I have just cleared my exams as a chartered accountant. I have become a fresh qualified CA and I am going for job interviews. As per my biodata, as per my CV, I have an expectation in my mind that I have drawn a probability distribution for myself, the salary and the probability. Salary here means the starting salary in my first job. Say the salary, average salary, say 8 lakhs per annum, fine, 10 lakhs. And say 15 lakhs. Okay. So starting salary. So I feel that the probability of me getting an 8 lakh package is around 0.4 and 10 lakhs is 0.3. 15 lakhs, and I also have international package, say it is 25 lakhs. You'll be happy to know that ICAI has started long back international campus. So as a chartered accountant, you can get the opportunity of working for global companies the moment you qualify. Now, so I say the minimum salary for international posting is 25 lakhs. So let me have, okay, this is my probability distribution. This is my own example, not there in the study material, additional example. So I have a salary, that means salary means the value which X can take. X is a random variable here. Okay, but why X is a random variable? Because I don't know what exact salary I'll be getting in my first job. Well, it depends on my knowledge, my interview performance, my communication skills, my leadership quotient, how good I am in group discussion, how well I can represent myself, how well I can sell my skills. So many factors, technical, interpersonal. So I don't know what salary I'll be getting. So it is unpredictable. It is not deterministic, which means it is a random variable. Is my salary X a discrete variable or a continuous variable? Normally, will I get a package like this, 8,35,250 rupees and 35 paisa. Will I get such packages? Yeah, theoretically possible. Yeah, 250 rupees they can pay me also. Not a problem. 8 lakhs, 35,000 rupees, 250. Normally, companies will not give such type of packages. They will give you a round figure. So 8 lakhs means maybe 8 lakh 10,000, but around 8 lakhs. So it is more of a discrete random variable, though theoretically they can give me this type of breakage also. Okay, but definitely theoretically, not practically. So it is a discrete random variable, not a continuous. Discrete random variable. Fine. So it is a random variable, yes. It is a discrete or continuous, it's a discrete. Now for each of the variable, X can take 8 lakhs value, 10 lakhs value, 15 lakhs or 25 lakhs. I have given the probability. Let me add up and see. 0.4, 0.3 is 0.7, 0.9, 1.0. So this gives me a probability distribution. Okay? This is a probability distribution. Now the question is, this is a discrete probability distribution, and this type of probability distribution will be represented by a formula. And after this we shall go into the formula also. Now the formula, please note, the formula for the probability distribution, the formula for any type of probability distribution, please note, if the probability distribution is a continuous, first let me take discrete. If the probability distribution is discrete, if it is discrete, like this one is a discrete, I am taking mostly the examples of discrete probability distribution. I will tell you why after some time. Why is it you might think, sir is taking only discrete examples. First example was defectives, then I talked about an example of a dice. Third one, I am talking about my salary if I join the campus as a fresh CA. I am taking discrete examples because I will tell you, just 2 minutes. So for every value there is a probability. So for discrete probability distribution, the formula which you will learn, that formula is known as the probability mass function. Please keep a note of it. I am writing for discrete is known as probability mass function. PMF, probability mass function. Please note, the probability mass function. Okay? Now, this is for discrete. Now, for continuous, I will write here. For continuous, like a continuous curve. Okay, continuous curve, two values x1, x2. Okay, so for a continuous probability distribution, like you have seen, I have already explained that example of discrete probability distribution, we have the binomial and the Poisson. Example of continuous probability distribution is when we talk about the normal distribution. Okay, now the formula which you will be learning, we shall be dealing with the formula for a continuous probability distribution is known as, here it's called probability mass function. In case of continuous, it is known as the probability density function. Density. Okay? So it is a PDF, probability density function. Okay, so please keep a note of this. Now in case of continuous probability distribution, why we try to find out the area within the curve? Because it is not possible to find out individual probability. Please note, it is not possible to find out individual probability for the values which a variable can assume if the variable is a continuous random variable. Once again, the salary which I have taken is an example of discrete variable. The number of defectives is an example of discrete variable. You can count them. Okay, if I become a CA in my first attempt or in my second attempt, okay, 8 lakhs, yeah, going by market conditions, 40% chance. Why? Why 40%? Because in the last year, out of 10 of my friends who qualified, 4 of them have joined different companies at an 8 lakh package. So 4 out of 10, 40%, so 40% for me. Are you getting the point? How 0.4 I am getting? Rough estimate. But these are for discrete. But for continuous, if you have to find out the probability of different, say for example, what will be the temperature tomorrow, or what will be the temperature of say your locality, your local place after 7 days, and it can assume any value. It's a continuous variable. For each of the value, finding out the probability is impossible because the values themselves are infinite. I talked about it. Countably infinite and uncountably infinite. In case of discrete random variable within a range, if the range is bigger, yes, it is countable, it is still countable, it is theoretically countable. But in case of continuous, it is not countable. For a continuous random variable, it is infinite, not possible, impossible for counting. If it is impossible for counting, how will you assign different probability value? Not possible. Here, since I know 8 lakhs, I can give a probability. If I know number of defectives is 4 or 5 or 10, I can fix a probability. But if the variable itself can take any value, literally any value, infinite values, then it is impossible for me to assign a probability figure. Therefore, we call it a probability density function, and we try to find out the probability between two intervals. Okay, I hope you are getting the difference between what is probability mass function and what is probability density function. Okay, now we go into the last part before starting with binomial theory. Now we will look at the properties of probability distribution. Okay, please note this. Very important part of our syllabus, a very critical part of this chapter. What are the properties of probability distribution? Okay, so we have talked about random variable, we discussed about what is a discrete random variable, continuous random variable, probability distribution. I explained it through charts, right? We had number of charts and tables. Then we talked about the types of probability distribution. Then I discussed about what is PMF, probability mass function, and why it is called, and probability density function and why it is called. Now we take up the properties. Okay, what are the properties? First of all, the property of any probability distribution, we are first taking discrete. So discrete probability distribution, what are the properties? First, so I will write some mathematical figures, and I'm sure you can now understand and follow with your good knowledge of statistics. Okay. Now, first of all, say the formula is fx. Right. That is, fx is nothing but the probability mass function. Okay. That is the formula by which you can understand what probability a particular value, at a particular value, what probability do we assign to that random variable. Random variable can take any values within a defined range. In case of discrete, any values means specific values, right? And in case of continuous, it can take any values, fine. But within the range, for every specific value, what is the probability? This is given by the probability mass function. The first point is, since it's a probability, so the property number 1 is that the probability will be greater than equal to 0 and it will be less than equal to 1. First property, please note. First. The second property. So you can understand that I said yesterday, last class also, that you have to work hard, and I am more than confident that you are all working hard to make sure that the probability of your passing the exam should be 1. That means the highest probability. That means you will turn your dream into a reality by completing successfully CA foundation. That means the highest number of any probability is 1, highest value, the lowest is 0. So 0 to 1. The second one is sigma fx has to be equal to 1. This I explained when I added all the percentage, like defectives. For one defective, probability is 15%. For two defectives, say 20%. In this way, when you add up the summation, sigma means summation, the total summation comes to 1. Very similar to the concept of integral. Please see the parallel. The maths and statistics are like brother and sister, or two brothers or two lovely sisters who have a bond. Think of it. They are real life, I see them as real life characters. So much of similarity. What you learn in statistics, sigma, and what you have learned in integral calculus, same. Both mean the same. Okay. So this is the second property. The third property is mean. Mean is known as mu. Okay. This letter is called mu. So, cat mews. So, mu. M-E-W, mu. Okay. So, mu, that is mean, is very similar to the concept of expectation which we did, mathematical expectation. So mu is given by sigma x into fx. Fx is the probability, x is the value. You remember we did that in statistics, in probability, mathematical expectation, the multiplication, the product of the value and the probability. So here the probability is given by fx, probability mass function, into the variable, the value, and sigma. Okay, summation of different values and their corresponding probability. This is mu. And we have variance. Last one is variance. You know, variance means it is the square of the standard deviation. This is given by small sigma. This is big sigma, capital sigma. The small sigma is given by sigma. Sigma square. This is variance, VAR. Okay, this is given by big sigma x minus mu. Mu is the mean. The mean is mu. X minus mu square into fx. Okay. So please note these four formula. Very important formula because questions will come on this. So mu is nothing but the mean. Standard deviation means the sigma is the standard deviation. So kindly note these four important properties of discrete probability distribution. I think it is now clear to you. The first one says that the probability will be always more than 0 and less than 1. So it is more than 0, P is more than 0 and less than 1. First one. The second says that the summation of all the probability will be equal to 1. So sigma fx is 1. The third is mu. Mu is also, you can call it also the expected value. Expected value. Okay? Or the mean. This is equal to sigma x into fx, where fx is the probability mass function and x is nothing but the x is the value. So we have the multiplication of x and fx. And lastly we have sigma square, which is the standard deviation square. This gives you the variance. This is equal to sigma x. X is the variable. X minus mu. Mu is the mean. X minus mu square. So the deviation, this is the deviation. Deviation square into fx. The deviation square into the probability. This sigma of this gives you the variance. So these four are very important. This is the mean, this is the variance. I hope this is clear to you, dear friends. The four important properties of the probability distribution. Okay. Now we go to the binomial distribution 17.2. So our foundation work is over and I think you are now clear with what is variable, what is random variable, what is a discrete random variable, what is a continuous random variable, and what is meant by probability mass function, probability density function, and also with the terms which we are discussing here and the properties. Okay. So we are moving now to binomial and we will see the probability mass function for binomial. Okay. Now the binomial PMF, the probability mass function for binomial 17.2 binomial. The probability mass function is given by NCX, p to the power x q to the power n minus x. This is the only formula which you need to remember. Okay. Now, for the binomial, we are thankful to the well-known mathematician Jacob Bernoulli. Many of you in physics, if you have had a science background, you may have read about Bernoulli's principle. He did a lot of work in aerodynamics, and while I was studying aviation, I had to study Bernoulli's principle in pressure, in different other areas of physics. And Jacob Bernoulli was born in 1654 and he passed away in 1705. So, old, 1654 to 1705, that was his time. And he gave us this distribution. He was the father of the binomial distribution, you can say. And this entire process is known as Bernoulli's process. Bernoulli's process, or sometimes called Bernoulli's principle, Bernoulli's experiment. Okay, so Bernoulli's process. So you see NCX, P to the power X, Q to the power N minus X. NCX you all know, C is combination. So what we learned in permutation and combination. Here N gives you, what is N? Now let us note each of them. So this is the probability mass function. N is nothing but N is the number of trials, the total number of trials. Trials means experiment, how many experiments you are doing. Trial is what? Trial is an attempt to produce an outcome. It is like an experiment. Throwing of a dice, tossing of a coin, introducing a new product in the market. These are all examples of trials. Okay. So these are trials and these are called Bernoulli's trials or Bernoulli's process. N gives you the number of trials. Each trial will have only two mutually exclusive outcomes. Please note, every such trial will have only two outcomes. I am drawing a flow chart. Please note with me. The two outcomes will be either a success or a failure. Like head or tail, either success or failure. Please also remember that these trials are independent. Okay, are independent. Plus, the number of trials, N, that is N, number of trials, will always be a finite positive number. A finite positive number, and the number has to be integer, cannot be a fraction. So it has to be positive, finite, integer. No fractions. Okay? So please note what is N. X is the variable. P is what? P is the probability of success. So I am writing P is the probability of success. For one trial, for one. So the probability of success for a coin tossing, the probability of getting head is 0.5, half. So here P is half. But the total probability for getting 10 heads, at least 10 heads, out of 15 tosses will be given by the PMF, this whole. But for individual experiment, for one trial, yes, the probability is half in case of a coin tossing. Okay? So, P is the probability of success, and also please remember that Q is nothing but the probability of failure. And this is given by 1 minus P. That means P and Q are two mutually exclusive and exhaustive events, because two of them cannot happen together. If P happens, Q cannot happen. If Q happens, P cannot happen. So they are mutually exclusive, two separate. At the same time, when they combine, you get 1. That means P plus Q will give you 1. Therefore, Q is 1 minus P. So, please, once again, let us see the PMF, NCX, P to the power X and Q to the power N minus X, where N is the number of trials. Every trial will have two outcomes. One will be a success, the other is a failure. The number of trials has to be a positive finite integer, and P is the probability of success, Q is the probability of failure given by 1 minus p, and this probability will remain unchanged. So p will remain unchanged. That means as you go on throwing the dice, or you throw the coin, you toss the coin. Okay, as you go on tossing the coin, the question is the probability of a head is half. The probability will not change. It will remain the same. It will remain constant. So probability will remain unchanged. It will remain constant. Okay. So please note that this formula is given in 17.1. The formula 17.1 in the study material. This is given. I have discussed it, and we have also seen the conditions for the Bernoulli's process, or if you call it the Bernoulli's principle in statistics, and you can see it is combination NCX, p to the power x, q to the power n minus x. You need to remember only this one. This is the probability mass function for binomial probability distribution. And definitely you can see that x can take any positive finite integer value. So x can range from 0, 1, 2, 3 up to n. N being a finite positive integer. Okay. Now let us see some examples, and this is not a very difficult formula, p to the power x, q to the power n minus x. So we have discussed about the binomial PMF. Now we go into some examples, and we'll get into number of interesting examples on binomial distribution. And you can see that these type of distributions are very useful, especially in certain areas, like in case of manufacturing. I was talking about, I was giving the example of the defectives, probability of defectives and probability of, a particular product which has high quality, no defectives. Now, if a person, say the company is manufacturing electric lamps, bulbs, lamps. Now, by understanding the probability of the defectives and by going through the probability mass function, the quality control department will be able to understand what is the probability for how many defects, and they will be able to arrive at a solution in order to extend the life of the lamp by suitable technological intervention. In the area of defense, now a missile is thrown. The target is an enemy camp, enemy establishment. A missile is thrown. It has two outcomes. Either it destroys the camp or does not destroy. So by studying the effect of a particular type of missile, the Ministry of Defense they can understand, the scientists who are helping can understand how many missiles are necessary to destroy say for example an army position belonging to our enemy's army position across the border. Why? Because a missile launching is an example of a Bernoulli's process, because it will have two outcomes. Either it destroys, it hits the target, or it does not hit the target. Okay. Similarly, for social areas also, social changes, say for example, for introducing no smoking signs, or for finding out, how many people are getting disease due to smoking, how many people are getting infected with lung cancer due to smoking. So the probability, the number of people who are getting infected and the probability. If you study the probability distribution, the government can understand which area in the country or what type of advertisements to bring up, so that people are given warning, people understand the evils of passive smoking and active smoking. So whether it is manufacturing, whether it is service industry, whether it is defense, or whether it is social change, binomial distributions are followed everywhere, and we can make suitable, management decisions, and we can also bring changes. Okay. Now let us take the example number 1. So I have already explained the probability mass function. We have seen that probability mass function in case of binomial NCX, p to the power x, q to the power n minus x. That means I can say that if you see once again NCX, p to the power x, q to the power n minus x, That means if you know the value of n and if you know the value of p, then your problem is solved. Because you know q is nothing but 1 minus p. So if you know p and n, you get the full details of the distribution. So this is the PMF, probability mass function. Also, this is why, please note, question often comes in the exam. Some people were asking me that, sir, do we get theory questions? Yes. For probability as well as for theoretical distribution, you may get an MCQ. Maybe it is based on a theory. So my request to you, please go through theory part also. Theory, never think that theory is useless. Only numericals are important. Never. Unless you know theory, you cannot solve the numericals. Theory is the base. Theory is the foundation. Never reject theory. Never avoid the theoretical part. That is why questions often come from theory also. Right? So, if you talk about the theoretical part here, now this type of distribution, the binomial distribution, is also known as biparametric. Biparametric. What does biparametric means? Bi means 2. Okay? Parametric means what? So biparametric means it has 2 parameters. What are the 2 parameters? N and P. So this N and P, if you know, then you get the full probability mass function. Therefore, N and P are the 2 parameters, and that is why it is called biparametric. Plus, if you note that the function, say this is fx, this probability mass function is fx. Now that means f0 plus f1 plus f2 plus up to fn. Okay, this will be equal to 1. So very important property which I explained, that sigma fx is equal to 1. Sigma fx is equal to 1, where x ranges from 0 to n. So f0, function f0, f1, function x equal to 2, function x equal to 3, plus the function x equal to n. The total probability has to be equal to 1, and please note it is a biparametric because it has 2 parameters, and n and p are the 2 parameters of binomial probability distribution. Okay? So, once you know this, you can easily find out the probability distribution. Okay, now some more important points. So, please keep noting. Biparametric we have discussed. So, biparametric. Okay. Now we look at the mean, the variance. Very important. And the formula are given from 17.1 onwards. So now we look at the mean. Now the mean of this PMF, the probability mass function, is given by mu. And this is NP. N is the number of trial, P is the probability. This is mean. The variance. The variance is basically, you know, standard deviation square. This is equal to NPQ. So I can write the standard deviation is square root of NPQ. So please note the mean and the variance. Now the question is, since P and Q are fractions. See, P and Q are all fractions because they are less than 1. So if you multiply NPQ, okay, NPQ will always be less than NP because both are fractions. This means that in case of binomial distribution, the mean of the distribution will always be more than the variance. So please keep a note of this as well. NPQ will always be less than NP, which means the variance will always be less than the mean, or mean will be more than the variance. Also, the last point is the maximum value of the variance. When will NPQ, variance is NPQ, when will NPQ have the highest value, the maximum value? Now the maximum value of NPQ will be, the NPQ max will be when P is equal to half, that is 0.5. In other words, P and Q, 0.5. So when Q is 0.5, P is also 0.5. That means at that point, NPQ will be N into 0.5 into 0.5. That means N by 4. This is the maximum value of NPQ. This often comes as a question in the exam also. Okay. So we have seen the binomial present probability mass function. We have seen that this probability mass function is applicable in cases where you have two outcomes. You have two outcomes for each of the trial. It is also known as Bernoulli's trial, Bernoulli's process, and there are two trials, two outcomes, either success or failure. The probability of the success remains the same. Even after 10 trials, the probability of the individual success will not change. We have also seen that in this case of probability distribution, binomial, we have also seen that one of the important parameters, or if you say one of the important property, is that it is only applicable in case of those numbers, that is n, this n which you see, number of trials, n has to be a positive finite integer, and it will have probability of success is P, Q is the probability of failure, and P and Q are the only two outcomes, right? Success and failure. That means they are mutually exclusive and they are exhaustive because P plus Q has to be 1, has to be equal to 1. And we have seen the parameters. Mean will be given by NP, variance is given by NPQ. So the standard deviation is nothing but square root of NPQ, and NPQ will have the maximum value when Q is equal to 0.5. Plus, mean will always be more than the variance in case of the binomial probability distribution. Okay, so we have done all the necessary understanding we have developed. Why binomial distribution, the applications of binomial, the probability mass function, we have analyzed it. Plus, we have gone through all the important properties of binomial. Okay. We also discussed in the beginning about the probability distribution features, which you must have noted, right? Now, the last one is, we have seen the mean, we have seen the variance. Now, there is mode also. So, we need to look at the mode. Okay. Now, let us see the mode of these type of distribution. Now, mode is given by mu 0. Okay. The way to denote mode is mu 0. Now, mu 0, that is mode, will be the largest integer. So, you first have to find out, you know, n plus 1 into p. First, you see n plus 1 into p. If n plus 1 into p is a non-integer, say it is a non-integer, in that case, what will be the mu? The largest integer which is contained in non-integer. For example, n plus 1 into p is comes to 10.35. Say, n plus 1 into p comes to 10.35. That means the largest integer within 10.35 is what? Is 10. Maximum integer value below 10.35 is 10. That means the mode, that is mu 0, is equal to 10. So please keep a note of this as well. And now we will see few questions. The first one we are taking up is, if one coin is, if you toss a coin, okay, so we have seen the mode. Of course, if this is in case when n plus 1 into p is a non-integer. Now what happens if n plus 1 into p is an integer? So we'll just take that one. Now if this is an integer, non-integer, but if this is an integer, then we will take the largest integer in n plus 1 into p minus 1. Okay. So if you find that n plus 1 into p is an integer, then we will take the largest integer in n plus 1 into p minus 1. Okay. Lastly, there is one more point which we will note and that is in case of two distributions, if you have two independent distributions x and y, both are binomial probability distribution, and they have the parameter x as the parameter n1, this n1, and p, probability of success is p. Also, y has the parameter n2, and there also the probability is p. In that case, x plus y, so this is x, this is y separately, but now x plus y, they will have the parameters n1 plus n2. They will have n1 plus n2 and probability will remain p. So in this case, n1 plus n2 will come here. Instead of ncx, it will become n1 plus n2 cx when you want to find out the probability mass function of x plus y, and the probability will remain as p. So this p remains as it is, this p remains as it is, only this n1 is added with this n2 and we get n1 plus n2. Okay, so these are, if you see we have discussed in detail formula 17.1 to 17.6 of the study material we have done. These are the formula, but the main formula is the probability mass function NCX p to the power x q to the power n minus x. Okay, now we are ready to take up the questions. The first one, if you are tossing a coin 20 times, please note, problems are fairly easy. Once you remember the formula, nothing to worry. It's a direct question and there will be no twists and turns. Simple question. So we are now taking up properties we have done. Now we are taking up problems. Okay. The first one is a coin is tossed 20 times. So coin is tossed 20 times. What is the probability of getting exactly 10 heads? 20 times. What is the probability of getting exactly 10 heads? Okay. So very simple here. You can see that probability of a head, if you toss the coin once, is half. So P is half. Q is the probability of failure. Q is 1 minus P. P is half. So Q is also half. N is 20. N is 20. And you have to find out 10 heads. That means X is equal to 10. X is equal to 10. So in the probability mass function, it will become 20C10. NCX. 20C10. P, that is half to the power 10. Q is also half. Half to the power 20 minus 10. NCX, P to the power x, Q to the power n minus x, 20 minus 10. That means this will be 20C10, half to the power 10 and half to the power 10. Okay, now if you simplify and find it out, approximately 0.176. This chapter you will have to use calculator very fast, because in many of the cases the alternatives which will be given, if you get the alternative, one of the answer is this, then you are lucky, I will say. But if this answer is given as one of the alternative, that means you have to work it out, right? So it depends on the question, not possible to predict. Okay, so this depends on the type of question and the form of the answer given. But please note, it's a direct application of the probability mass function. Okay, the first one. Now we are taking up example 17.2. Example 17.2 of our study material. Okay, please open 17.2. Okay, if 15 dates are selected at random, we are taking 17.2. I'm sure this is clear to you. It's a direct application of what we have done, the probability mass function. 17.2, please open. 15 dates are selected at random. What is the probability of getting 2 Sundays? So we are doing 17.2 example. 15 dates you are selecting at random. That means you can understand here n is 15. You are selecting 15 dates at random, what is the probability of getting 2 Sundays and X is 2? So we have got N and X, but we have to find out probability of getting 2 Sunday. Okay, now in a week there are 7 days. So what is the probability of getting a Sunday? Randomly, if you are asked, I give you a date, say 23rd of September. What is the probability it is a Sunday? There are 7 days and your favorable option is Sunday. That means the probability is 1 by 7. 1 by 7. Therefore, Q is the success or failure. That means it is not a Sunday. Probability that it is not a Sunday is Q equal to 1 minus P. That is 6 by 7. So, what will be the probability that the question says 15 dates are selected at random. What is the probability of getting 2 Sundays? So, X is 2, N is 15, P you know, Q you know. Q is known to you. So, very easy now. The PMF probability mass function is given by NCX, P to the power X, Q to the power N minus X. So, I just put the values in the formula. N is 15, so 15 C2, P is 1 by 6, 1 by 7. 1 by 7. So NCX, so 1 by 7 to the power 2. And Q is 6 by 7, so 6 by 7 to the power 15 minus 2, that is 13. Okay. So this comes to around approximately 3, approximate. Okay. 0.30 approximate. Okay. So this is example 17.2, direct application of the probability mass function. Okay. Next one is very important. This has come in our MTP also. Very important question, and I will request you to flag it as a very important question. Okay. So we have done few problems. Already we have done 2 problems. Now we are doing 17.4. Example 17.4. Okay. Let us see 17.4. This has also come in the CA MTP May 2020. Okay. This was there in the question. Very important. Find the probability of a success for the binomial distribution, and the condition is 4 into probability x equal to 4. Please note 4 into probability of x equal to 4 is equal to probability that x equal to 2. And the parameter n, I am writing here, n is 6. So this came in the exam, I mean the model test paper in the mock test. Okay. So many questions keep coming which are part of the study material. So I will request all of you to go through each and every problem in the study material, and you may get common problems in the exam. Okay. So CAMTP question. So probability of success, 4 into probability that x equal to 4. This is equal to probability that x is equal to 2. 4 times of this probability is equal to P that x is equal to 2. Probability that x is equal to 2. N is the parameter you know, NCX. N is given as 6. So we first write the PMF. The probability mass function I am writing again and again so that it's easy for you. NCX p to the power x into q to the power n minus x. Okay. So now we will try to solve it. It is given x equal to 4. So I will first write this one. 4 into probability that x equal to 4 is what? NC4. P to the power 4. Q to the power n minus 4. This is equal to probability that x is equal to 2. That is NC2. P to the power 2. Q to the power n minus 2. But n is 6 given. N equal to 6 is given. So we simplify this. It becomes 4 into NC4. 6C4, P to the power 4, Q to the power 6 minus 4, that is Q to the power square. This is equal to NC2, that is N is 6, 6C2 into P square into Q to the power 6 minus 2, that is 4. Please see. So this, if you further simplify, this will ultimately, if you further simplify this, it will become, once you equate them, once you are equating this 4p into this, ultimately after simplification, it will come to 60, because 64 is 15, so it comes to 60, 15 into 4, 60, 60 p to the power 4, p4q square. This is equal to 60 to 15, 15 p square into q to the power 4. So now if you take 15 p to the power square and q to the power square common, then first this side it becomes 4 p to the power square minus this side is coming here, this is coming q square. So 15 p square q square into 4 p square minus q square comes to 0. Please see. Up till now I think it is clear. We have first done 4 into this, probability that x is equal to 4 is equal to x, probability that x is equal to 2. So we have just created the probability mass function. We have put the value n equal to 6. We are getting 60 p4q2 is equal to 15 p2q4. Now we have transposed this to the left hand side and this is what we are getting. 15 p square q square, that is 15 p square q square into 4 p square minus q square equal to 0. This is what we are getting. Okay. Now the question is, let us see what further we can do. So question is 4 p square q square. So that means this is equal to 0 means 4 p square minus q square. Can it be 0? Sorry, first this one. P square q square. Can it be equal to 0? Please check. P square q square, can it be equal to 0? Is p equal to 0 or q equal to 0? Not possible. Not possible. That means this part is not 0. So this part is 0. So 4p square minus q square is 0. Now we will simplify. I am writing here. 4p square minus q square is 0. 4p square minus q square is 0. But we know q is equal to 1 minus p. So it becomes 4p square minus 1 minus p square equal to 0. Please note, I have replaced q and I have put 1 minus p. Now this is of the form a square minus b square. So I can write 2p whole square, because that is 4p square, minus 1 minus p whole square is 0. Which means I am getting a square minus b square. That is, you know, a square minus b square is equal to a plus b into a minus b. So a plus b will be 2p plus 1 minus p. This multiplied by a minus b. So 2p minus 1 plus p is equal to 0. So this means, the first one, it means 2p minus p is p. P plus 1 into 2p plus p is 3p minus 1 equal to 0. Which means p plus 1 equal to 0 or 3p minus 1 equal to 0. P plus 1 equal to 0 means p is minus 1. Will you accept p equal to minus 1? Can probability be negative? No. So this is wrong. Okay. Therefore, the next alternative is this. 3p minus 1 equal to 0. So 3p minus 1 equal to 0 means p equal to 1 by 3. So therefore the probability is 1 by 3. The answer for this question is that individual probability will be 1 by 3. Very, very important question. That is why I have solved the entire part. And you can see at the end again there is quadratic equation, and very, very important question for your exam, because it is there in the example plus it is there in the May 2020 MTP. I hope you have followed and you can see why we have taken P equal to 1 by 3. Okay, now let us take number 17.5. We are taking 17.5. Okay, we are taking 17.5. Okay, find the binomial distribution for which mean is given. The mean is 6 and the SD, standard deviation, is 2. Lovely question. Okay, we know that the binomial distribution probability mass function is given by NCX p to the power x q to the power n minus x. Okay, mean we know mu equal to NP and standard deviation SD equal to 2. So variance is equal to 2 square, that is 4. But we know variance is NPQ. Okay, that means NPQ divided by NP, if you do, you are getting 4 by mean is 6, 4 by 6. So NP cancels, Q is equal to 4 by 6, that is 2 by 3. If Q is 2 by 3, then P equal to 1 minus 2 by 3, that is 1 by 3. Please check. Therefore, we are getting the value of P equal to 1 by 3. Now, mean is given NP equal to 6. NP is 6 and P we have already got 1 by 3. So, N into 1 by 3 is 6. That means N is equal to 18. 6 into 3. So, we have got N, we have got P and we have also got, if P is obtained, Q already we have got, Q is 2 by 3. So, the probability mass function here we will write 18 Cx, P is 1 by 3, so 1 by 3 to the power x and 2 by 3 to the power 18 minus x. NCx, Px, Q to the power n minus x, and n is 18. So this is the answer, 18Cx, 1/3, 1 by 3 to the power x multiplied by 2 by 3 to the power 18 minus x. Okay. Okay, one more question, 17.8. This is important because it has come in the May MTP, May 2020. So I think you have followed it and it's clear. You can see direct application of the binomial probability mass function as well as the formula for mean and the standard deviation is important. And mean is NP and the standard deviation is given by square root of NPQ, which means the variance is NPQ. Now we are taking up example 17.8. Also very important because this is a question which has come in the May 2020 MTP. So we are doing simultaneously the questions of the example as well as the MTP. So 17.8 and let us see what question is there. An experiment succeeds 3 times after it fails. So after failing 3 times, I get a success. Again 3 times I fail, again I get a success. Right? If the experiment is repeated 5 times, what is the probability of having no success at all? Fine. Let us understand and we write. Experiment succeeds 3 times after it fails. So after failing, I pass. Failing, I pass. So I can say that probability is 3Q. Depending on the probability, here the relation is P is equal to 3Q. Okay, which means that if probability is 3Q and we know that P plus Q has to be equal to 1 because P is the probability of failure, success and Q is the probability of failure, and if P is 3Q, right, so we can say that 3Q plus Q equal to 1, which means 4Q is 1, so Q is 1 by 4. If Q is 1 by 4, then P will be 1 minus 1 by 4, that is 3 by 4. So now we know P and Q. Experiment is succeeds, okay, we have done. If the experiment is repeated 5 times, what is the probability of getting no success? So the question gives you the answer. The question itself says experiment is repeated 5 times, that means n equal to 5, and probability of no success, that means x will be 0. No success, x will be 0. Therefore, if you see, what will be the probability mass function in this case? So NCX 5C0. Probability of success is 3 by 4. So 3 by 4 to the power 0. And failure is 1 by 4. 1 by 4 to the power 5. This is your probability mass function or PMF. 5C0, if you calculate, 5C0 is equal to 5C5, that is 1, into 3 by 4 to the power 0, anything to the power 0 is 1, into 1 by 4 to the power 5. So 4 into 4 into 4 into 4 into 4. 16 4s are 64, 4s are 256, 4s are 1024. So I am getting 1 by 1024. This is my answer which I am arriving for 17.8, looking at the parameters which are given in the problem. So P and Q relationship we know, and from there we just substitute the value of P and Q in the equation, because we know that binomial probability distribution, the rule is that P and Q have to be exhaustive and mutually exclusive also. So only 2 outcomes. From there we get P's value, Q's value, and from there we put it in the probability mass function and we get the required probability. Okay. Now we go into exercise 17A, set number A. So I request you to move to example exercise 17A. And we will take the questions. We are first taking set A. I will be taking questions from set A, set B, set C, and also the additional questions. Okay. First is set A number 2. You will see that number of questions are coming on theory also. So we are taking set A, B, C and additional. First we are taking number 2, set A. Okay. The first question is probability distribution may be discrete or continuous or infinite, or option D is A or B. You know, we have already discussed probability distribution can be either discrete or continuous. Therefore, option number D is correct. That is A or B. It can be either discrete or continuous. So number 2 is done. Number 3. An important discrete probability distribution is Poisson or normal or Cauchy or log normal. Already we have discussed that probability distribution is of 2 types. We have the continuous probability distribution and discrete. Discrete, I took the examples. First is binomial and the next is Poisson. And the continuous probability distribution, if you talk about the continuous probability distribution, it is normal. Normal probability distribution is an example of a continuous probability distribution. Therefore, in this case, the answer is Poisson. So 3A, option 3A. For number 2, the option is 2D. Okay. Now we go into number 7. Question number 7. This is set A. A trial is an attempt to do what? Option A, make something possible. No, wrong answer. Make something impossible. Wrong answer. C, a very funny one. Prosecute an offender in a court of law. Well, trial, you know that we always hear the word trial. Trial means court, trial means judge, trial means prison if I get convicted. But here, no such violent scenes. Trial here simply means an outcome which is, an attempt to create an outcome which is neither certain, it is uncertain, but it is possible. Okay, so I will say not impossible, it's possible. So 7D is the right answer. We go to number 10. Okay, so if x is a binomial variable with parameters n and p, then x can assume, please see number 10, any value between 0 and n. Okay, it sounds good. Any value between 0 and n. But the right answer is any integer whole number value. I told you repeatedly, I told you that you cannot get fractional value. Number of defectives cannot be fractional. Okay, number of attempts I take in an exam. cannot be fractional. So I can take any attempt to crack a difficult exam, but it has to be a whole number. Okay. Therefore, in number 10, you will see the third option, any whole number between 0 and n, both inclusive. That is the right answer. So 10C. I go to number 12. Okay. The mean of a binomial distribution with parameter n and p. We know the mean is mu, which is given by np. Let us see the option. Option C is the correct one. 12C. Going to number 18. Okay. The maximum value of the variance of a binomial distribution with parameter n and p. We have already seen that I did it a little while back, that the variance maximum will take place when q is equal to half, 0.5, which means npq will become n by 4. Let us see which option. Option B, n by 4. So 18 option is B. With this we complete set A. I will now go to set B. Okay. So in set A we have done 2, 3, 7, 3, 4, 5, 6. 6 questions we have done in set A. Now we go to set B. Okay. So you can see fairly simple chapter. Only issue is you need to be clear with the understanding of what is random variable. We spent a lot of discussions on that. We did what are the types of random variables and probability distribution, the types, the basic concept, right? The table which I drew, you remember, defectives and then the outcomes which you get when you throw a dice along with the probability plus the probability mass function you need to remember. Once you do that, rest of it is just direct application. Okay, set B I am taking number 3 first. So set B I am taking the first one 3. If B and P, if X the parameter are given n and P, what would be the greatest value of the variance when n is 16? We know that variance maximum is given by n by 4. Now here it is given that n is 16. Therefore the variance will be 16 by 4, that is 4. So I think the second option, question number 3, option number B is the right answer. We are going to number 5 now. So let's take number 5 and see. What is the number of trials of a binomial distribution having a mean 3 and SD is 1.5? So mean, okay, I'll write in our language, not in layman's language, in our language. All of us are mathematicians now. So I'll use the term mu. Okay, mu is given by, mean is 3. Okay, mu is 3, fine. And SD is 1.5. So SD means sigma square is 1.5. Fine. Now, you have to find out what is n, number of trials. So n we don't know. You know mean. Now mu is equal to np, that is 3. Sigma square means variance. It is given by npq. This is 1.5. Therefore, npq by np, npq by np is 1.5 by 3. np cancels out. So you get q equal to half because 1.5 2 times. If q is equal to half, therefore p is equal to 1 minus half. Because you know p plus q is 1. So p is equal to 1 minus half, that is half. So you know p, you know q. So let us see, you have to find out n. Now np is 3. np is given, np is 3. So p is half, np is 3. Just check. Okay, just a sec. We will check the question. Mean SD, sorry, SD is 1.5. No, then variance. I took variance. No, it will be 1.5 into 1.5. Yeah, because variance. It's not variance, SD. SD is 1.5, so variance is 1.5 into 1.5. So it will be 2.25. So if it is 2.25, then here it will become 2.25 by 3, which means 7.75 3 by 4. Yes, 3 by 4. So Q will come to 3 by 4, not half. It will come to 3 by 4. Okay. If it comes to 3 by 4, so be very careful when you read the problem fast, because while doing it, sometimes you may miss a particular step, because instead of like for example, you see, just in time I was able to see the question. I quickly saw that I had written variance. It will be SD, and SD variance frequently creates confusion. Okay. So now I have taken the corrective action. Q is 3 by 4. So P is 1 minus 3 by 4. That is 1 by 4. P comes to 1 by 4. Now if P is 1 by 4, NP is 3. So N into P is 3. P is 1 by 4. Okay. So N into 1 by 4 is 3. That means N is equal to 4 into 3. That is 12. So my answer is coming to N is equal to 12. Out of the options which are given, let me open the question. The question I'm just opening. Options, yeah, it is D. So I think this is 5, question number 5. The option is coming to D. Okay, good question, and really, once you know the formula, it's easy. Now we take number 6, question number 6, set number B. So B we have done 3, 5, now we take 6. 3, 5, 6. Okay. So rub it out. Please try to work out the problems with me parallelly. Number 6. What is the probability of getting 3 heads if 6 unbiased coins are tossed simultaneously? Okay. Number 6. What is the probability of getting 3 heads if 6 unbiased coins? So you can easily understand here N. The number of trials is 6 because 6 coins are tossed. So number of experiment, or if you can say Bernoulli's trial, is coming to 6. So N is 6. Okay, N is 6. And we have to find the probability for 3 head. So X is equal to 3. N is 6. X is 3. So we directly put the probability mass function NCX, P to the power X, Q to the power N minus X. Here N is 6. C 3. Okay. Question is biased coin, unbiased coin. So you know for a coin the probability of a head is half. So I directly put half. Okay. Half to the power 3. And Q is also half. If P is half, Q also has to be half. Half to the power 6 minus 3. So 6 minus 3. So 6 C3. So 6 P3. 4 into 5 into 6 by 6. So I think it comes to 20. Just check. I'm doing fast. So just check. 20 into 1 by 2 to the power 6 minus 3 is also 3. So 3 and 3 is 6. So I am getting 20 divided by 2 to the power 6. So it gives you 2 to the power 6. So 2 into 2 into 2 into 2. 1, 2, 3, 4, 5 and 6. 4 to the 8 to the 16 produce 64. So it gives you 20 by 64. That is 10 by 32. That is 5 by 16. 5 by 16. That is what I am getting. So 5 by 16 will give you a decimal. Right, 5 by 16 will give you a decimal. Just check 5 by 16. I think you will be getting 0.32 approximately. So approximately 0.32. Let's see the answers. Options are given 0.50, 0.25, 0.3125 and 0.6875. So 0.3125 is the correct answer. So for 6, the option is C. Okay, this is how we solve. We are now taking up number 8, question number 8. Set B, question number 8. Okay. So I hope you are following the way in which I am solving each of the problems, and I hope with more and more practice, definitely you are reaching a higher level of confidence. Number 8. What is the probability of making 3 correct guesses in 5 true and false answer type question? Very simple, 5 true, false answer type question, which means 5 trials. So N is 5 and probability of making 3 correct guess. So x is 3. So direct application, it becomes 5C3. Now question is correct guess. Correct guess means what? Correct guess means that the probability will be half, right? So therefore 5C3 half to the power 3 correct guesses. So half to the power 3 into half to the power 5 minus 3, that is 2. So 5C3, let's calculate 5C3, 3 and 2. Okay, so 4 into 5 by 2. So it comes to 10. 10 into 1 by 2 to the power 5. So 2 to the 4th, 8, 16, 32. So 10 by 32. That is, again, we get 5 by 16. So 0.3125. This is the answer which I am getting. Let's see the options. Yeah, we have this answer in one of the option A. So we will tick A, 8A. Okay. Now we are moving to set C. Okay. We move to set C, dear students, and we'll take the questions. I am taking set C now. So already we have done 6 questions in set A and 4 questions in set B. We are taking set C. Number 1, we are doing number 1. Set C. Please check the question. If it is known that the probability of a missile hitting a target is 1 by 8. So probability is 1 by 8. What is the probability that out of 10 missiles fired, at least 2 will hit the target? Beautiful question. Lovely question. Appreciate the Board of Studies experts who have made these type of questions. Beautiful question. So, the probability of success is 1 by 8. Okay? Therefore, the probability that the missile will miss the target, will not be able to hit the target. So, Q will be 1 minus 1 by 8. That is 7 by 8. Okay? Fine? Now, 10 missiles are fired. At least 2. What is the probability that out of 10 missiles, at least 2 will hit the target? Please be very careful with at least 2. At least 2 will hit the target. That means, basically you have to find out, at least 2 means what? You have to find out function of 2 plus function of 3 plus so on till function of 10. But this will be a very tedious job. You will take a lot of time. So what we do is we find the complement of this event. Okay. At least 2 means, what is the complement of this? That means it will hit 1 target or it will hit 0 target. So the complementary of this probability, if I call P is equal to F2 plus F3 plus F10 till F10, the complementary of this will be what? The complementary will be 1 minus P. Basically, it will be what? F0 plus F1. So if you find out the probability of this one, and if you subtract this from 1, you will be getting the required probability. So P is this. I have taken 1 minus P dash. It will be this. In fact, P dash is this. Sorry, P dash is this. Okay. So we will find F0 and F1. You know that N in this case is 10 missiles, I think. 10 missiles are fired. So N is 10. For 0 hit, that means X is 0. So the probability mass function will be 10C0. P is given 1/8. 1 by 8 to the power 0 into 7 by 8 to the power 10. This is the probability mass function when F is 0. So I am showing it with an arrow, F0. Plus, we will do F1. For X equal to 1, that is F1, it will be 10C1. 1 by 8 to the power 1. 7 by 8 to the power 9. Because 10 minus 1 is 9. You have to add this plus this. If you add them, you will get 0.6388. 0.6388. That means the probability of hitting, the probability that the missile will either hit one target, right, or at least one missile will hit the target out of 10 missiles, or none of the missiles will hit the target. The probability is this. So this is the probability of F0 and F1. Therefore, we have to find the complement of this. So 1 minus this figure 0.6388, 1 minus 0.6388 will give you the probability that at least 2 will hit the target. So 1 minus 0.6388 gives you quickly 0.3611 approximately. So 0.3611 coming, and you will see, I think, out of the options given, option D. So question number 1, answer is D. This is a lovely question, and you can see here the very useful. You please note that for set C, in the questions which are there in set C, each of the question I think carries 5 marks. So these are quite advanced, and a lot of steps are there where you have to improvise and you have to find out the proper way to deal with these questions. So here you can see F2 plus F3 plus, if you go till F10, it is whatever probability it gives. Go and try to compute the complementary set, the complement of that, 1 minus that probability. So that is easier. F0 plus F1. F0 we found out, F1 we found out. We add up the probability and we subtract that from 1 so that you get the probability of this. Okay. So this is a very good question. With this we move to number 3. Question number 3, set C. Okay. Question number 3, we move to set C. Question number 3. Yes. Assuming that 1/3 of the population are tea drinkers and each of 1000 enumerators takes a sample of 8 individuals to find out whether they are tea drinkers or not, how many enumerators are expected to report that 5 or more people are tea drinkers? Okay. So this is number set, we have done 1 and 3. Okay, number 3, set C number 3. Here, if you see, 1/3 of the population is tea drinker. It is given 1/3 of the population drink tea. That means the probability that a randomly picked individual will be a tea drinker is given by 1/3. So I can say P equal to 1/3. Probability of a tea drinker is 1/3. Why? Because 1/3 of the people, 1/3 of the entire population are drinking tea. Okay. Therefore, you can easily understand that randomly if you pick a person, right, we will get 1/3, P equal to 1/3. Now, question is, N is given 8 individuals. So, N is 8. X is given 5 or more people are tea drinkers. 5 or more people. Okay. So, ultimately if you see here, X is 5 or more, greater than equal to 5. So X can assume the values. If you see a sample space, that means what are the values X can assume? It can be 5 or 6 or 7 or 8. So X can assume these values because it is more than equal to 5, but definitely it has to be up to 8, less than equal to 8. That means in this case, we have to find out the probability mass function PMF for X equal to 5 plus X equal to 6 plus X equal to 7 plus X equal to 8. All the probabilities. 4 probability mass function you have to work upon. Which means if I write, this will become NCX, that is 5, N is how much? N is 8. So 8C5, 1/3 to the power 5, 2/3 to the power 3, 8 minus 5, plus 8C6. This is for X equal to 5. Now for X equal to 6, 8C6, 1/3 to the power 6, 2/3 to the power 2, plus for X equal to 7, 8C7, 1/3 to the power 7, and 2/3 to the power 1. And for x equal to 8, 8C8, 1/3 to the power 8, 2/3 to the power 0. Now if you add it up, that is F1, F5 plus F6 plus F7 plus F8, it is approximately coming to 0.08, sorry, 0.08775. 0.08775. This is the answer which I have got. 0.08775. This is the probability. Now the number of enumerators are 1000. 1000 enumerators are finding it. And you have the probability 0.08775. So the number of enumerators will be 1000 into 0.08775. That is approximately, it will be around 88. So answer is 87.75. Nearest whole number is 88. So my answer is coming to 88. And going by the options given, the nearest option is 88. So C, PC. Option number C is the correct answer here. As per what I have got, you can just check it with the given answers, 3C. Now we take the last one, and this is number 5. Set C number 5. Okay. Set C number 5. I will try to keep the additional questions, probably we'll do next in the next session possible. Some of the questions from the additional question bank. Let me take this one as the last one, and then we will go into the responses to the questions which came on probability. Okay. Now number 5, if you check, out of 128 families with 4 children, how many are expected to have at least one boy and one girl? As I said, that binomial probability distribution is applicable for finding out those type of cases where there are 2 outcomes, like head or tail, success or failure. So here it's either boy or girl, 2 outcomes. So let's take the question number 5. Out of 128 families with 4 children, we are trying to find out how many expected to have one boy and one girl. Now here, please see that P equal to probability of a male child, boy, is half. Probability of a girl child, Q, is also half. This is okay. Now we try to find out what are the possibilities. Now with 4 children, you have 4 children. Fine. Okay. 128 families are there. Okay, 128 are there with 4 children each. How many expected to have one boy, one girl? Now what are the combinations? To have one boy, minimum one boy, one girl. Option number 1, you can have 3 boys and 1 girl. 3 boys, 1 girl. Option number 2, you can have 2 boys and 2 girls. Because you have to satisfy minimum 1 boy, 1 girl criteria. 1B, 1G criteria. Okay. So the 2 options I have got here is 3B, 1G and 2B, 2G. The third option which I am getting is, it can be 1B and 3G. 1 boy and 3 girls. These are the 3 alternatives which are possible. So from the boy's perspective, if you see, if you take P as the probability of a boy, you are getting 1, 2 and 3. In other words, we have to find F1 plus F2 plus F3. That's all. And you know F is the probability mass function, that is NCX, P to the power X, Q to the power N minus X. If you work it out, here you will get N is how much? N is given, I think, just checking, out of with 4 children. So N is 4. Okay. So if you find it out, that means it will be for one boy, it will be 4C1, half to the power 1, half to the power 3, plus for F2, 4C2, half to the power 2 into half to the power 2, plus 4C3, half to the power 3 into half to the power 1. Right? So if you solve it, you will get 7 by 8. This entire probability will come to 7 by 8. Now we have how many families? 128 families. And the overall probability is 7 by 8. So out of 128 families, how many families are expected to have at least one boy and one girl? Well, it will be 128 multiplied by 7 by 8. So it comes to 8 ones are 8, 16, 16 sevens is 112. So my answer is 112. Let's see the options: 100, 105, 108, 112. Okay, so we have got it. This answer is coming to 5D, 112. So dear friends, with this we are wrapping up the discussion on the probability distribution. We first started with random variable. We looked into the types of random variable, discrete and continuous. Then we took up the discussion, detailed discussion on probability distribution along with charts and tables. We discussed about the types of probability distribution, and I also showed you the two types, that is the discrete probability distribution where we have binomial distribution and quasar, and for the continuous distribution we have normal distribution. We also discussed about the probability mass function, which is the normal formula for binomial and for quasar, and for normal we use the PDF, probability distribution function. Then we looked at the property of binomial, the biparametric nature of binomial. Then we did the problems. We took 17, 1, 2, 4, 5 and 8. Then we went into the example, the exercises 17A. We solved from set A, I solved 6 questions. From B, we did 3, 5, 6 and 8. And from set C, we did 1, 3 and 5. Right? And good to know that we also completed the questions which have come on this chapter in the CA MTP May 2020 exams. With this, I am wrapping up this part. I am taking the balance 10-15 minutes quickly to discuss about the issues which are there on the probability chapter, which we did in the last day. I will just take the important questions. I hope you are through with this particular chapter on binomial distribution and you are clear with that. Okay. So let me just take the issues which are there on the probability. So number of questions are there which I'll take up. So questions I have responded to many of you. Vanshika, Diksha, Shushobhan Fadikar, he asked, is probability used in data science? Yes, it is used. Diksha asked whether to do additional question bank. Yes, please do it. Vanshika was asking about revision lectures. Well, it depends on the decision taken by the Board of Studies. Also for Shushabhan, I will only say that probability is used very much in artificial intelligence while working on financial modeling. Personally, I work a lot in financial modeling and big data. We use a lot of probability concepts there. Tejashri was asking, sir, probability is all about future events. Yes, but based on past trends. You can see here we are forecasting the future based on the past trends. Sayali Patil, got late to decide for CA. Sayali, please check ICAI CA Tube in YouTube and you will be getting the full access to all the last, the old lectures also. Anisha, is ICAI material enough? MTP and RTP are very important, Anisha. Vivek, could we say that business is an experiment? Well, Vivek, yes, from the statistical point of view, starting a business is like an experiment. Don't take it literally in the meaning of experiment. But take it in the meaning of experiment from, like you see the word trial. Bernoulli's trial does not mean court trial. Doesn't mean the trial which is held in court. It has a different meaning. Similarly, experiment. Business is an experiment because it will give you two outcomes, either success or failure. Okay. Ria, Arora and Sahil. Okay, they were asking whether BCom and BB are important to do with CA. Well, yes, because some companies later on, they prefer a person who's a CA along with definitely a graduation degree. Okay, Karishma, what is the weightage of probability chapter? I think I've explained. Around 6 to 7 questions can be expected. Vanshika had a question about your calculator. Vanshika, I have responded. Please see the ICAI guidelines. Normally 6 functions, 12 digits and up to 2 memories. Please check the specification of your calculator. If you have tax and rate, I think possibly it will be a scientific calculator, may not be used, but please do check the exact specifications. Akanksha Ramdas Umbarkar, sir, do we have to do the sums which you have taught or accept them the extra? Extra also. You see, we have a strict time of 2 hours. I always take some more time. I am sorry to Board of Studies and ECPL team for that. My apologies, because they have a back-to-back session, but I do it not for my sake, but only for your sake. The more I can give within this time, even if we stretch the time, it is important because once again, mathematics and statistics are pure practical. Different types of problems, so many formula. It is not like memorizing theory. So that's why it's better to do some extra problems also. Okay, Maniak has a question. I will respond. You can contact BOS for that. Whatever problem you are facing, please try to contact BOS. Ishita Srivastav, is theory questions asked in the exam? Yes, you can see here in set A, all the questions which we did, many of them are theory questions. Navya, is mutually exclusive and disjoint the same? Well, Navya, mutually exclusive means one of the two events has to occur. If there are two outcomes A and B, right, events or outcome, if A occurs, B cannot occur. At the same time, I explained through Venn diagram on the last day, you remember, disjoint, it will be disjoint. So it is definitely mutually exclusive events. From the Venn diagram point of view, definitely will be disjoint. So if there are two outcomes A and B, if A takes place, B cannot take place. They have nothing in common. That means A intersection B is 0. So they are disjoint. Okay. Sahil Raj, how can we know whether the particular event is independent or not independent? In the exam, Sahil, in many cases, in the question it will be mentioned that these two events are independent. Moreover, you have to use your logic to see whether the events have any connection, whether they can influence each other. Okay, so like India winning a particular match, right, may not have any influence with me passing in my exam. So these are two independent events. India winning a match and me passing an exam, both happening at the same time, right, possibly has no connection, cannot influence. So they are two independent events. Okay. I'll take up the questions now, some conceptual issues. Aditi Shah, Raj Lakshmi Saha and Vaibhav. Question is how exhaustive events are different from mutually exclusive. Well, mutually exclusive events means if A happens, B cannot happen. Exhaustive means that either A or B has to happen. That means A plus B will be equal to 1. Like in case of the binomial, you saw that it deals with only two outcomes. So in case of a particular issue, say for example, throwing a dice, you can have 1, 2, 3, 4, 5, 6. If 2 comes, if you get 2, that means you have got 2, not 6. If 2 is what you get on the dice, 2 means 3 cannot come, 4 cannot come. That means they are mutually exclusive. They are exhaustive means that in whichever way you throw a dice, either of 1 to 6, either 1, 2, 3, 4 or 5 or 6 has to come and it cannot be something else. So it is nothing but a sample space. This 1 to 6 is a sample space which contains all the outcomes which are possible in that experiment. Okay, so this I think Aditi, Raj Lakshmi and Vaibhav, you are clear. This is the difference between mutually exclusive and exhaustive. Exhaustive means one of them has to occur and mutually exclusive means if 2 takes place, 3 cannot take place, 4 cannot take place. Okay. Next one, Mayank Baskara. What is P into the probability of A into B? I think we did discussions on this detailed. PAB means nothing but PA intersection B. So from a Venn diagram perspective, A is here, B is here. This intersection is A intersection B. If A and B are independent of each other, I just explained what is independent. In that case, you know PAB is equal to PA into PB. But if they are dependent, one can influence the other. Like in the last class I mentioned about the CA journey, right? Once I do IPCC, then I can go for articleship. So the probability of articleship, probability of me joining articleship depends on my completion of IPCC. So they are in a way related, they are in a way connected. One can influence the other. In that case, you know conditional probability PAB will be PA into P of B by A. Right? So I hope Mayank you are clear with this now. Vijayita Sinha has asked a question, what is the difference between mutually exclusive and independent? Vijayita, I think you are now clear with what I discussed. Independent events means, as I said, two events which have no influence on each other. Mutually exclusive means two events But mutually exclusive concept, please understand, is for the same experiment. Throwing a dice, same experiment, two possible outcomes. They are mutually exclusive. Independent event means two different experiments taking place altogether, where no experiment can influence the other experiment, or the outcome of one experiment cannot influence the outcome of another experiment. Okay, so as I said, a match, cricket match is an experiment. Two outcomes, India wins or loses. Another parallel experiment, Mr. Ram starts his business. Whether Mr. Ram is successful or not, there are two outcomes. And India winning or losing are two outcomes. So these two are independent events. One cannot influence the other. They are not related in any way. Okay? Vijayta, I hope you are clear. Sahil, Raj and Anushka Lakshmikant Kernat have asked about De Morgan's law. Just quickly explaining that. Okay, so De Morgan's law. If you see De Morgan's law talks about 2 points, you'll be surprised to know that De Morgan's law is used in practical life as well. Just as we use binomial distribution, Poisson, we also use De Morgan's law. De Morgan's law actually gives us this relation A union B intersection, that is complement. This is equal to A intersection A complement intersection B complement. This is the first law of De Morgan. And the second one is just the opposite. A intersection B complement is equal to A complement union B complement. So these are the two laws which are there and which are used also in, not just in set theory or Venn diagram, but also used in probability theory. So I think Sahil and Anushka, you have got your answer. Okay, there was a problem last day on cards, right? So card problem. So you remember, I think this was problem was 16.4, example 16.4, and it has also come in the MTP card problem, playing cards, pack of cards. So it's in the MTP also, in the May 2020 MTP. The problem number I found out is 82, same problem. Some of you have sent queries and maybe you are a little confused. Arnav Bajaj, Aditi Shah, Pratyush Agnihotri, Ankit Sharma, Dhruv Saini and Thyaneshwar D and Aishwarya. Question was, what is the chance of picking a spade or an ace not of spade from a pack of 52 cards? Well, 52 cards are there. Fine. So 1, 2, 3, 4, 13 each. Okay, 13 spades are there. 13 spades are there. Okay, and each one has an ace also. The question is, we have to pick either a spade or an ace which is not from the spade. So S can belong to the other three categories, and the other three categories are hearts H, clubs C and diamond D, and this is spade. Okay, now if you see here, this is there in the solution also, just explaining. This actually uses the formula P A union B. Here P A is the probability of a spade, and probability of B, PB, PA is spade. Probability of B, PB is that you are picking an ace. Okay, now the question is, we know that PA union B is equal to PA plus PB minus PA intersection B. You know this and we have discussed this many times. PA, the chance of a spade is 13 spades by 52. The chance of an ace, if you see, what is the chance of an ace? I can take any of these three. This. So 3 by 52. The question is, it is true that if I am taking 13 spades here, the ace is included. Yes, I got your point. But for this question, please note, for this question, the ace belonging to the category of spade, please note, the ace which belongs to the category of spade is treated as a spade. It is treated as a spade. Right? Say for example, you are a CA as well as a PhD. CA as well as a doctorate. Primarily you will be treated only as a chartered accountant. I mean, don't take it otherwise. People will respect you first because you are a chartered accountant. Because you know, a CA degree is one of the toughest degrees to acquire. Similarly here, even though the A's belong to the category of spade, right, for this question and from the spirit of the question, the A's which is here in the spade is treated as a spade. So 13 spades we are considering, and we are considering the 3 other aces, 1, 2, 3. So 13 by 52 plus 3 by 52, that comes to 16 by 52. I can understand your issue. Some of you were thinking that it should be not 13 but 12, because the ace should be removed. So it should be 12 by 52 plus the remaining 3 by 52. Answer should be 15 by 52. But for this question, I took up the question, I analyzed it myself, discussed it with Board of Studies, experts, and the question is basically, my thought was also, I also mentioned 16 by 52 on the last day, and it is based on this formula. And here, the ace is treated as a spade. The ace which belongs to the spade is treated as a spade. Right? So, if you see the question, answer is coming to 16 by 52, and it is a correct answer given in the study material. And it's also MTP question. You will see in the MTP, options are given, and 4 by 13. This will reduce to 4 by 13. 4 by 13 is given as an option. I hope Arnav, Aditi, Pratyush, Ankit, Dhruv, Thyaneshwar and Aishwarya, you are now clear. And many of the others also who had some confusion, I think you are clear. That's why I gave the example of CA and PhD. Like the ACE is like a PhD, but since you have to do CA first, then you can do PhD. And the CA is I would say a very, not just tough, but also respected globally. So you will always be first known as CA so and so, then PhD. Similarly here, you will be known more as a spade and not as an ace, right? So that is the spirit of the question as I understand. That is why we take PA as 13 by 52 and PB as 3 by 52, because we will not take this ace. We will consider only the 3 aces here, which belongs to hearts, clubs and diamonds. Okay. Fine. Sample space question came from Nitendra Nath Vashisht. I think I have explained it. Sample space is the solution space for all the possible outcomes which can get generated from an experiment. I will take a lovely question which has come from Vijayita Sinha. Possibly this is the last one I am taking, and one more I will take, just 5 minutes more. A question which came in the MTP. First I will take the question from Vijayita Sinha. Thanks Vijayita for sending an interesting question. What is the probability that four children selected randomly have different birthdays? So 4 children have different birthday. They have different birthday. Good question. 4 children. Okay, first child comes. So they are A, B, C, D. First child comes. Okay. Whatever birthday. Okay. Forget. Whatever she has any particular birthday. Say 15th of Jan. So we are assuming 365 days in a year. 365. So now B's choice will be different birthday. So 365 minus 1 by 365. Total number of possible cases 365. But since one birthday is already allotted, A has a birthday 15 Jan. So B has a choice of 364 days. So basically it is 364 by 365. C will have a choice, again one birthday is going to B. So C's choice will be 363 by 365 and D's choice will be 362 by 365. So if you see, the answer is 362 into 363 into 364 by 365 cube. Right, so looking at it, looks like a very high probability, of course. My assumption is around 98. 0.98 approximately, I may be wrong, but this is what I am getting looking at the numbers. Just by looking at the numbers, I get the feel that this will be close to 98%. But this will be the answer, no doubt. I am 100% sure about it. This calculation you just do and find out. My gut feeling says 97 or 98%, close to 98.98. Fine. I take the last one, that is CA-MTP question. Okay. Right. One similar question which I am doing, this is CA-MTP 2020 question number 83. The last two questions, and I am winding up in just less than 5 minutes. 83. Find the probability that a 4-digit number having the digits 2, 5, 6 and 7 will be divisible by 4. Please see the question number 83. This is May 2020. It is divisible by 4. So 4-digit number, very good. You know, divisibility rule is for any number whose last 2 digits are divisible by 4 will also be divisible by 4. This is clear. That means out of these numbers, the last 2 digit, if the last 2 digit is 556, it will be divisible by 4. If it is 76, divisible by 4. If it is 52, divisible by 4. And if it is 72 also, it will be divisible by 4. Now, based on your understanding and knowledge, you now have a high knowledge. All of you, I have high regards for you. You have a high level of knowledge in permutation and combination. Expert level knowledge. With that knowledge, you can understand 4 numbers, these 4 digits can be placed in 4 places. In how many ways? 4p4. That is 4 into 3 into 2. That is 24 ways. Out of which 56, if you have 56 as the last 2 digit, if you place 56 here, the remaining 2 digits can be placed, 2 numbers can be placed in 2 ways. So here I have 2 ways. Again for 76, if I keep 76 here, 2 digits can be the remaining 2 digits. 76 is here. That means 2 and 5 has to be placed. Either it will be 2, 5 or it will be 5, 2. So 2 ways. Again 2 ways. Similarly for 52, 2 ways. And for 72, 2 ways. Okay. So what we are getting here is that we are getting for all these cases possibilities, right? Each of them is a possibility. So we use the addition rule. So we are getting 2 plus 2 plus 2 plus 2 by 24. Okay. That is 8 by 24. That is, I think, 1 by 3. It's coming to 1 by 3. Okay. So for each of these are all possible options. 1, 2, 3, 4. And for each of this, there will be a combination of 2. Permutation of 2. If you keep 5, 6 here, 5 and 6, that means it will be either 2, 7, 5, 6 or it will be 7, 2, 5, 6. So 2 possibilities. Right? So this is a question. I think there is one of our friends, Sonal Munka, who sent a similar question. Sonal, you have sent a long list. I'll try to take some more time next day if possible and respond to some of your questions. But this is one question which you sent. The last one with which we end is question number 86. Very important question. And MTP question means very, very important for your exams. This is the last question of today, 86. The question is, PA is 2/3. Okay, so PA is 2/3, 2 by 3. PB is 3 by 5. PB is 3 by 5. PA union B, probability of A union B. PA union B is 5 by 6. You have to find PA intersection B. Beautiful question coming in. So here we directly apply PA in union B equation. You know PA union B is equal to PA plus PB minus PAB. PA union B is given 5 by 6. So 5 by 6 is equal to PA. PA is 2/3 plus PB is 3 by 5 minus PAB. You don't know PAB. So if you just transpose this and solve this, you will get PAB is coming to 13 by 30. If you take the LCM and 6, 3, 15, we just find out it's 13 by 30. Now you know you have to find PA by B. You know the conditional probability formula PAB is equal to PA, okay, into, PB into PA by B. Conditional formula. There are two formulas. PA into PB by A or PB into P of A by B. Here we need A by B. So A by B you will get how? PAB divided by PB. You will get PA slash B. That means the answer is PAB you have got 13 by 30. So 13 by 30 divided by PB. PB is here 3 by 5. Divided by 3 by 5, that means 13 by 30 into 5 by 3. So it comes to 13 by 18. My answer is 13 by 18. This is what I am getting. 13 by 30 divided by 3 by 5. I have to check the answer. Please check the answer. 86. So this is 13 by 18. So we took PAB formula, placed all the values, we got PAB. From PAB we use the conditional probability formula, PB into P of A into A slash B, right? So we use the conditional formula and found out PA by B as 13 by 18. So with this we end, but before ending, thanks a lot to many of you who welcomed me back in the session last day. Simran, Sushavan, Ushakala, Ishita, Prachi Pandey, Mayank Prajapati, Vanshika, Rahul Kumar, Kunal, Sahil Raj, Utkarsh, Sweetie, Arnab Bajaj, Anushka Lakshmikant Khairnar, B. Gayatri, Jasmine Kaur, Annapurna, Vijay Lakshmi, Latika, Navya, Rukmini, Satvik, Pratham, Madhusudan Kabra, Kunal Jain, Jay Kumar, Sai, Chetna Agarwal, Isha Jain and Komal. So I thought that I should mention your names. Thanks for welcoming me back. This is more like a family. We have now become a family. It's a VCC family. Our objective is only one: success, quality and becoming chartered accountants in future. So with this, dear friends, I end the session today. Tomorrow we'll take up the session on Poisson, and I'm sure now binomial distribution is clear to you. Plus I could clarify the doubts which you had and also did some extra problems on probability. Right? With all probability, we will be back tomorrow at same time 2 o'clock. And thanks to ECPL team, thanks to Board of Studies, thanks to all of you for joining. Wish you good luck, go on practicing and see you tomorrow.